Hi guys, welcome back. Today we are going to talk about operations of complex numbers. So first I'll kind of introduce to you what complex numbers are, and then we will do day one today. We will do addition, subtraction, and multiplication. And then day two, tomorrow, we will do dividing. Okay, so this is in your Springboard book on page 126. So you can go ahead and grab that and then a pen or a pencil for notes and possibly your calculator. Okay. So on the top of page 126, you'll see our learning targets here, which state that we are going to add and subtract complex numbers. And again, today we're just going to multiply complex numbers, and tomorrow we will divide. Okay. So perform addition of complex numbers as you would for addition of binomials of the form a plus bx. To add such binomials, you collect like terms. So first of all, let's talk about what a complex number is. And a complex number is a number that has a real and an imaginary. So it's always written in this form a plus bi, where a is the real part of the complex number, and bi is the imaginary part. So that's kind of an important piece of information here moving forward. So it says that we're basically doing the same thing when we were combining binomials in the form a plus bx, but now they're in the form a plus bi. And you can only, when it says like terms, here, you can only collect them if like the A's are going to go together and the BI's are going to go together. So the reals and the imaginaries go together. Okay. And again, here it says the only difference is that the X is now an I. Okay. So you can see in example A, the different steps here, and they just collect like terms and then they simplify. So 5 plus negative 2 gave them the 3, and then 4x plus 3x gave the 7x. Okay. Same thing here. 5 plus negative 2 gave them the 3, and 4i plus 3i gave them the 7i. So it's very similar. Okay. So let's go ahead and take a look at examples A, B, and C here. So 6 plus 4 is 10. And then plus 5i, whoops, I shouldn't have put the plus there. 5i plus negative 7i is a negative 2i. And you could write it in the parentheses, or you really don't need the parentheses either. You're just writing it as a complex number. Okay. Same idea here. Negative 5 plus negative 3, negative 8. And then 3i plus negative I is 2i. And then let's take a look at this last one. 2 plus negative 2 is 0. And 3i plus negative 3i is 0i. So this whole thing is just 0. Because everything cancels. 2 and negative 2, 3i and negative 3i, everything cancels. So it's 0. Okay. So that's just adding. And again, you're just combining like terms. Okay. Subtraction, very similar, but this is going to be important here. You need to distribute that negative. So I'm actually going to rewrite this first one, and I'm going to write my first complex number the exact same, 12 minus 13i. But then what I'm going to do is I'm going to distribute that negative to everything in the second set of parentheses. So the minus times negative 5 is going to be a positive 5. And the minus times 4i is going to be negative 4i. And then because we've distributed that, now we are adding in the middle. So now it's just like a problem we did on the last page. So 12 plus 5 is 17. Whoops. And negative 13i plus negative 4i is negative 17i. So you get 17 minus 17i. Okay. All right, and then this last one, be careful because there is subtraction and addition. So maybe you want to take it in 2 steps here. Or you could just do like 8 minus 3 plus negative 5 and just combine all of those at the same time. So 8 minus 3 is 5, plus negative 5 is 0. And then go ahead and move on to the i's or the imaginaries. Negative 5i minus 5i is negative 10i. And then plus 10i is 0i. So this is another one where it ends up being just 0. Okay, because everything canceled. All right. So basically the big thing is with adding, you're combining like terms. With subtracting, you have to distribute that negative and then combine like terms. Okay. So now let's go ahead and move on to multiplication. And it says here, perform multiplication of complex numbers as you would for multiplication of binomials. The only change in the procedure is to substitute I squared with negative 1. So this is important here. All right. So remember that the square root of negative 1 is equal to I. So if we were to square both of these, to get rid of the square root, that would look like negative 1 equals I squared. So that's where this comes from, and I would definitely have this written down somewhere that I squared is equal to negative 1, okay? Because now anytime we get an I squared in our answer, we're going to, as it says here, substitute that with a negative 1, okay? So yeah, here are your steps over here. And multiplying these are very similar to binomials where we would FOIL or box method, your choice. And then you would combine like terms. And then the only difference is this step 3 here where we have to replace I squared with negative 1 and simplify once again. Okay. And when we simplify, again, we always want it in this form a plus bi. Okay, you can't flip that and put like the imaginary first. It always has to be real, then imaginary. Okay. So this example is really good. You guys can take a look at that. And then we're going to do these 2 examples together. And then you guys will try C on your own. Okay. So I'm going to do these on the next page just so I have enough room. So first one, multiply the complex numbers. We have 6 plus 5i and 4 minus 7i. And in this first one, I'm going to use FOIL for those of you who prefer FOIL method. So I am going to do my first times my first. Okay, so 6 times 4 is 24. Then I'm going to do my outers. So I have 6 and negative 7i. So 6 times negative 7i is negative 42i. Then I'm going to do my inners. So 5i times 4 is 20i. And then I'm going to do my last. So 5i times negative 7i is a negative 35i squared. So it's literally the exact same thing we were doing a couple weeks back. It's just instead of x, now we have I. And then we're going to go ahead and combine like terms here. So then we'd be left with 24. Negative 42i plus 20i is going to be negative 22i. And then minus 35i squared. But here we are going to plug in, whenever you see this I squared, you're going to actually plug in a negative 1. Okay, remember that? I squared equals negative 1. So we got to remember to plug that in. So we do 24 minus 22i minus 35 times negative 1. And that's always being multiplied because 35, this was 35 times I squared. So now it's negative 35 times negative 1. So that's going to give us a positive 35. So 24 minus 22i And then, like I said, that becomes a positive because it was a negative times a negative. Okay, so then we now can combine these like terms. So we end up with, 59 is our real 24 plus 35, and then minus 22i. And that is your final answer there. And that we found using our FOIL method. Okay. Awesome. Then let's try one more using box method. And so I'm going to go ahead and draw in my box here. And I have 2 minus 3i. That's my first complex number. And then I have 3 minus 2i. And then you're going to multiply each box. So 3 times 2, 6. 3 times negative 3i, negative 9i. Negative 2i times 2 is negative 4i. And negative 2i times negative 3i is a 6i squared. So now I would go ahead and combine these like terms. So I'm going to write this as 6. Negative 4i plus negative 9i is negative 13i. And then plus 6i squared. And again, before you're finished here, you need to replace that I squared with negative 1. So 6 minus 13i plus 6 times negative 1. And then we need to do 6 minus 13i, and this is going to be minus 6 because it's a positive 6 times negative 1, so negative 6. And what actually happens here is when we combine like terms, 6 and negative 6 cancel, so your final answer is just negative 13i. And if you were worried about writing it in the a plus bi form, you could write it as 0 minus 13i, but you could just definitely say negative 13i as your final answer. Okay. Alrighty. So the next one I want you guys to try on your own. Okay, so you can FOIL or box method, and then combine like terms. And then whatever you get for your I squared, you're going to plug in a negative 1 instead, and then simplify again, and make sure it's in this form, a plus or minus bi, whatever the sign is, but it's got to be in that form. Okay, so hopefully you paused the video, and here is the work for this one. So you should be getting, if you FOIL or box method, 25 plus 10i plus I squared. Then plug in the negative 1 for I squared. So 25 plus negative 1 is 24 plus 10i. So this is your final answer here. Okay. So that's really it for adding, subtracting, and multiplying complex numbers. Tomorrow we'll do some more of these in class, and then we will move on to division in our next video. Okay. So let me know if you have any questions, and have a good one. Bye-bye.